Hello friends, welcome to Live Fair Do Mathematics. The problem today we are going to discuss is the problem of NDA exam 2020. Okay, the problem says what is the modulus of the complex number cos theta plus I sin theta by cos theta minus I sin theta where I equals root minus 1. Okay, so here we will apply the formula mod z1 by z2 equals to mod z1 by mod z2. Okay, so now look here, z1 is cos theta plus I sin theta. Z1 equals to cos theta plus I sin theta, and z2 is cos theta minus I sin theta. Then what is mod z1? Mod z1 is root over cos square theta plus sin square theta. Okay, so what is this? This is cos square theta plus sin square theta equals to 1. So this is root over 1, and that is equals to 1. And mod z2 is equals to root cos theta square. Okay, so mod z2 is cos square theta plus minus sin theta square. Okay, so this will stands for cos square theta plus sin square theta. Okay, and this gives root over 1, that is equals to 1. So mod z1 equals to 1 and mod z2 also equals to 1. So mod z1 by mod z2 equals to 1 by 1 equals to 1. Okay, so option B will be the right answer. The next question is, consider the proper subset of 1, 2, 3, 4. How many of these proper subsets are superset of the set 3? Okay, so first let us suppose that the given set is X, that is X equals to 1, 2, 3, 4. Then we construct the power set of X. Okay, so now what will be the power set of X? It usually consists of phi, singleton 1, singleton 2, singleton 3, singleton 4. Okay, now we have considered all singleton sets. Now the doubleton sets we will consider. Okay, so there will be 1 2, 1 3, 1 4, 2 3, 2 4, 3 4. Now we have considered all the doubleton sets. Now we will consider subsets containing only 3 elements. So 1 2 3, 1 3 4, 2 3 4, 1 2 4. Okay, and now the set X itself, that is 1 2 3 4. Now what we have to find? We have to find supersets of the set 3. So the supersets of 3 of the set singleton 3 will consist of element singleton 3 and some other elements from the set X. Okay, so obviously phi cannot be in the superset, 1 cannot be there also. For same reason these sets will be not there. Okay, now this set does not contain 3. Okay, so this set cannot be a superset of singleton 1, singleton 3. Now this subset contains 3 and 1, so this is a superset. So the only possibilities are 1 3. Now for the same reason 2 3 will be a subset, and that will be the superset of singleton 3. For same reason 3 4, 1 2 3, 1 3 4, 2 3 4 and 1 2 3 4. So the number of supersets are 1 2 3 4 5 6 7. Okay, so option C is right answer. Okay, so now we have solved this problem by considering superset, power set. Now we will solve this problem by combination. So this is our method 2. Now superset of 3, we have to find superset of singleton 3. Okay, now superset of singleton 3 will consist of, will be, the set will seems like this, 3 and something small x, where x is some other element from the set capital X other than 3. Okay, so x cannot be 3, but x can be 1, 2, 4. So what are the possibilities of x? We can choose x from 1, 2 and 4. So we can choose any one of them. So we can choose out of 3 one element, that is 3. In 3C1 there are 3C1 possible choices. Okay, now we can choose also, this set can be 3 of x this type. Okay, so we can choose 2 elements for the same region, and all, if we choose all the elements, so 3C3. Okay, so now what is 3C1 is 3, 3C2 is also 3, and 3C3 is 1. So this is 3 plus 3 plus 1, so this is 7. So we have solved the problem in 2 ways, and in both ways we have got the answer 7. So option C is the right answer. Our next question is, let PQR be 3 distinct positive real numbers. If D, that is determinant PQR, QRP, RPQ, then which one of the following is correct? So we have to find the determinant of this. Okay, so let us find that. So given, we can find this like this. Now this is given this PQR, QR, P, okay, and RPQ. Okay, so now perform the operation. C1 dash equals C1 plus C2 plus C3. Then what we will get? We will get this P plus Q plus R, Q, R, here again P plus Q plus R, R, P, P plus Q plus R, P, Q. Okay, so now we can take P plus Q plus R out, so we will get 1 Q R, 1 R P, and 1 P Q. Now we have to find the date of this matrix. So what can we do now? 1 times RQ minus P square, okay, plus, sorry, minus Q times, what we will have? Q minus P, okay, plus R times what? P minus R. Okay, so now we can write this as this. RQ minus P square minus Q square plus QP plus RP minus R square. Okay, so now we will take minus out of this bracket. Okay, so we can write this like this, minus P plus Q plus R. Okay, then what? This bracket will reduce to like this, P square plus Q square plus R square minus PQ minus RP minus RQ. Okay, so now we have to do some operations. Now we multiply by half P plus Q plus R, then multiply this bracket by 2. So this bracket we can write this like this, then 2P square plus 2Q square plus 2R square minus 2PQ minus 2RP minus 2RQ. Okay, so what can we do now? So now we can write this as, this is equals to minus half times P plus Q plus R. Now we have to manipulate this bracket. Okay, look, how do we manipulate this bracket? We can write this as p square minus 2pq plus q square, okay, plus q square minus 2rq plus r square plus r square minus 2rp plus p square. Okay, so now what we have? Now we have minus half times p plus q plus r. Then we can write this bracket as p minus q tar whole square plus q minus r tar whole square plus r minus p tar whole square. Okay, so now what was given in the questions? Look, the options were d less than 0, d greater than 0, d less than equal to 0, and d greater than equal to 0. So now this is our d. Okay, so what can be d? And given that p, q, r are three distinct integers. Look here, given that, sorry, three distinct positive real numbers. p, q, r, three distinct positive real numbers. Okay, now if p, q, r are three distinct positive real numbers, since they are positive, so p plus q plus r can never be 0. Okay, so if this d is 0, then obviously this part has to be 0. Now if this part is 0, then this is the sum of the square of three real numbers. The real numbers are p minus q, q minus r, r minus r. Now as this is the sum of square of three real numbers, this can be 0 only when p minus q is equal to 0, q minus r is equal to 0, and r minus p is equal to 0 simultaneously. Then what we have? We have p equals to q, and from this we have q equals to r, and from this we have r is equal to p. So these three simultaneously gives us p equals to q equals to r. But that is an impossibility, because it is given that p, q, r are three distinct positive real numbers, so they can never be equals to. Okay, so this can never be 0. Okay, but here is a minus sign. Okay, look, p, q, r are three distinct positive real numbers, so their sum will be positive, and this is the square of three. This is the sum of three squares. Again, this is a positive real number, so this is positive and this is positive, and that is multiplied by minus up. So positive number multiplied by minus up will be a negative number. So this determinant d will be strictly less than 0. Okay, so option A will be the right answer.